Okay, so last topic for week 2. Hopefully, this is again a bit of a break after 2 straight hours of Python over the last day and a bit. The last topic's about teamwork, interactions, and operations. And in a lot of ways, this is the last lecture where you really need to absorb some of this for iteration 1. In particular, this is just how to function with your team. Now, the things that we talk about in this lecture are important things. Some of you would have been doing this before, though generally speaking, we don't have expected all the groups to have been thinking about these things between last Friday and now, because we haven't talked about it much. However, going forward from this weekend until it's due, so for the last 10 days before it's due, we do expect you to kind of follow what we've kind of stipulated and talked about in these lectures pretty seriously. We want you to do it. What we're learning about today is essentially how do a lot of teams function together. Practically, philosophically, mainly practically, but a little bit of philosophically. At the start, we're going to talk about what the hell Agile is, this word you hear about too much. Stand-ups, sprints, task boards, meetings, and minutes. There's a lot more we could talk about with this, but the purpose of this lecture is to keep it really high level, really simple. We're not going to get too into this is exactly how you do this and you use this tool and say this stuff. We're more trying to convey concepts and philosophies than particular practices, though there are obviously certain practices we'd like to see you really get deep into. So the first question, you've probably heard about this before. What is Agile? I mean, God, I hear about this word too often. It's actually heard about probably less these days. It seemed to have a big uproar in like the 2010s when everyone was getting really into Agile software development and whatnot. And most companies still kind of adhere to some of this stuff, maybe with a little less orthodoxy than in the past, but we're going to talk about what it means to us in this course. So the first thing about Agile is that when we refer to modern software practices, what we're really talking about here is not reading a book on sprints and Scrum reviews and stuff like that. We're really talking about a more dynamic way to build software with people. And there's 4 really important lines here I want you to pay attention to. In fact, let's just maybe go to the URL so I could zoom in a bit. And it's these 4 lines here. When it comes to more agile forms of software development, we are focusing on individuals and interactions over processes and tools. What that means is that we always need to have our priorities are focused on how humans interact and how they can talk with each other and how they can share, more than getting over the top about certain software items or tools. So for instance, the reviewing process for code is really important. It's really important that we spend time actually looking at other people's code, sharing with them, having those interactions on GitLab, rather than trying to build a perfect system that can test everything fully automated. We actually value people and interacting with them because that's quite critical to building good software. That's number 1. The second one is we value working software over comprehensive documentation. So we understand that because software is a rapidly developing thing, you're always working on it, it's going to be very hard to document things clearly all the time. While we should strive to document things as well as we can, reality is that our main priority needs to be working software. We need software that just works. We need to make sure our pipelines are passing and that master is stable. Because if we had to choose between a stable master and the correct documentation, we would rather a stable master, because a lot of documentation can become redundant pretty quickly too. The third thing is we focus on customer collaboration over contract negotiation. This is something that you're not going to get a great sense of in this course, but what that's saying is that when you work on a project such as UNSW streams, you don't want to say sit down for 10 hours at the start with someone and be like, okay, let's figure out everything you need to do. Let's write it down, and then I'll see you in 3 months. I'm going to go away and do it. There's an understanding that for good software to be built, you want to actually have an ongoing dialogue with the stakeholders involved. So the people who you're writing the software for, you're trying to show them demos, you're trying to show them progress as you go. This kind of collaboration is quite critical, and we prefer that over just trying to negotiate at the start and stick to it. The fourth point ties into that, which is that you and I and everyone else should prioritize responding to change more so than following a plan. So similar to the previous point, it's natural that in all software projects you have to change what you're doing. Maybe a technical implementation you thought about is a bit harder than you expected. Maybe it's less feasible than you expected. All of these things could be true, right? So being adaptable, being ready to respond, writing code that's ready to respond is really important. You know, in the case of this course, you're going to go through 2 major changes in both iteration 2 and iteration 3. And those changes are important to get right. And to do that, like, you can't just assume that everything you do at the start's never going to change. So these are 4 big philosophies. And you know what, when someone says to you Agile, what I would personally recommend is that you, like, this is what you should all take away, because I think that this method of software development is this kind of conceptualization of software development, modern software development in teams, this is high level enough and broad enough that you can pretty confidently apply this way of thinking to nearly any kind of software project you work on. When you get into the specifics about how teams meet and how they record and they use taskboard, that's all quite different. Like, different companies, different teams, they all do different things and have different opinions. But these things are pretty core, and these things are what you really need to keep in your mind. In terms of these, it's not saying that we used to do this one on the right and we're now going to do this one on the left. There's a nice summary here, which is that while there is value in the items on the right, while we care about those and we strive to do those, we do strive to follow a plan. We do strive to negotiate and agree on terms. We do strive to document. We do strive to have good processes and tools. Those 4 things are a lower priority than their respective partners on the left. Yeah, so that's the high level conceptualization of it. I've kind of touched on this already. I've kind of said, you know, this is a clear philosophy that informs a range of processes at different companies and different groups and different organizations, but most of them tend to follow the same underlying principles. A little bit of a misnomer. I think I meant to cut some of these slides out. I must have forgotten. I think these aren't meant to be here, these next 4 slides, but what I was just going to point out is that one area that, like, why Agile became a little bit more topical in the world of software is because most other kinds of engineering, mechanical, electrical, civil, blah, 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 while they all do try and be more iterative in their approach, they do try and be more agile, the fundamental nature of what you're doing, it's harder to be agile in those fields. Most of the time it's because you're dealing with physical constraints of reality. Like a good example would be, say, if you're working on a mechanical project, say you're designing a wheel rim, right? Something a car tire sticks on. You don't really have this ability to kind of learn a little bit from the customer, and then the customer maybe being a car manufacturer, and then go away and build a little bit, and then test it a little bit, and then, like, just keep building a wheel every single week. Oh my god. Okay, I don't know how audible I am. I assume it's okay. Alright. You know, you don't have that ability to iterate as quickly as you might do with something like software. So you can actually apply, like, a lot of these philosophies to pretty much any form of engineering. It's just that in software, because of the low cost and the low overhead of essentially throwing your stuff out and doing it again, or, you know, just iterating on it, and there's essentially no cost, it's, like, great, because you can just, like, you know, get onto it and keep going. So software, you see all these principles in engineering, but software, it's just sped up a little bit. It's just like faster, because the cost is so low. And when we talk about the software development life cycle in the previous lectures, that life cycle is something that doesn't happen over a year. It's something that kind of happens quite rapidly. You know, you learn a bit, you design it, you build it, you test it, you give it out. You know, I mean, there's a bit of nuance there. I'm simplifying it, but the point with the whole waterfall method is that you don't really follow these projects in reality where you go and figure out what you're doing, you design it, you build it, you test it, you're done. That's it. It is a leaf blower. Agile structural engineering, yeah, exactly. So, and again, different kinds of engineering have different things. Like if you're building a dam, like a water dam, you're not going to have the luxury to to build a little bit of the dam and then figure it out later. So some of these are overfitted a little bit for software. though I'd say pretty confidently that most software projects you would work on, no matter their scale or impact or whatever, would tend to follow somewhat similar approaches. Or if they don't, sometimes they'd at least benefit from it. Maybe not to the fullest extent, but they'd at least benefit from it a little bit. Now, what is some more so that's a conceptual idea about how you should think about how your software team functions, what matters to you philosophically. Some more tangible things that we're going to try and, instill upon you are just practical tips you can use to actually function as a group. And when we say tips, we're kind of saying you got to do this because it's a uni course, I guess. But one of the first things is the idea of stand-ups. So you might have heard about stand-ups before, or something like that. Stand-ups are essentially where you and your team get together, often have very short meetings that update each other on their progress. Generally speaking, you can ask, you can have no questions in that meeting. You can have a few questions in that meeting. A really simple structure that I generally suggest to people is what did I do since we last met? What problems am I facing, and what am I going to do between now and the next time we meet? The reason those questions are useful is so you can update everyone, but also so you can reflect on things. I think one of the misconceptions about stand-ups is that you're meant to always have... I got hiccups. No. You're always meant to have something to say, right? You're always meant to be like, oh, I did this yesterday. But in reality, stand-ups are more just so that people can actually keep in sync and reflect. It's totally fine to be like, I did nothing yesterday. I got caught in this problem. I'm still working on the same thing. That's normal, and it's good because then the team's aware of what your problems are. You're able to vocalize yourself a bit more. You're able to reflect on it, because reality is when we're all busy and stressed, we want to kind of pretend that our problems go away, right? Like if we have the thing due on Friday and it's Monday, if you have to say to yourself 4 times before that happens that I haven't done anything today, that's going to be really important for everyone, yourself included. Now, when I talk about stand-ups and you think about, typically it would be people coming into a room together for 5 to 10 minutes and chatting. Reality is that between changing nature of how software development is, as well as COVID-19 and everything else, nowadays what we see a lot more of is both online and asynchronous stand-ups. So a lot of companies are starting to move in this direction too, whereby instead of having like a specific meeting every day where everyone gets on a Zoom call or something and talks about what they did, which you can do and is a great ambitious thing to do, they more just have like a time every day between say 10 and 10:30 or 11, 11:30, 10:30, 11, whatever, where you just talk about, you actually just send a message to each other via your, say Microsoft Teams or whatever, where you're just like, yep, here's my few dot points, and then everyone can read it. So you have to write it, and then by say 10:30 you can go and read someone else's and you can have a bit more of a chat there. The reason they call them asynchronous stand-ups is because you don't all have to be there at the exact same time, right? Some of you might be there, for at the start and at the end and whatnot, and it falls into this flexible working environment idea that's becoming more popular. It helps you find a suitable time for everyone. It tends to work better with big teams, because otherwise the alternative is that if someone's not there, you miss out on their voice. The only downside with this is it's harder to solve difficult problems because you like find out about it and then someone's not there and then they take a few hours to reply. Asynchronous work of any kind has its problems as well as its benefits. You can see some longer term kind of cultural dissonance that happens where people feel less connected because they're not talking to each other as much. So, there's ups and downs of this. So this is pretty common. In terms of your own groups and your own experiences with the project, what I'd say is that asynchronous stand-ups are the most common way that students do stand-ups in this course. Because it's a uni course and you're not working full-time, what I'd say is that meeting every day is probably going to be overkill for most groups. It's going to be overkill for most groups, and that's okay. Like, you can meet every day. That would be awesome if you did, but most groups are just not going to have the desire to do that. So where things get more, I guess, specific to your project is that what we'd probably recommend is that you kind of meet up, maybe you do stand-ups maybe to 4 times a week. I'd probably recommend 3 to 4 times. Maybe Monday, Wednesday, Friday, Saturday, or Monday, Wednesday, Friday, Sunday, or something like that. 3 to 4 is good, even if you don't have anything to update. It's good to do like at least an asynchronous stand-up 3 to 4 times a week. Your tutor will be interested in this. They'll be interested in if you do this. Again, you should try and do this on Microsoft Teams, because then your tutor can easily check if you've kind of done this kind of stuff or not. It could be at any time of the day. Again, I probably wouldn't recommend less than 3, particularly because one of these will be a meeting anyway. I mean, probably a good thing for most groups is just 3 stand-ups and then your weekly meeting. Most groups should have a weekly meeting, which we'll talk about in a sec. Some of them do it during the lab time. Some of them will do it at a different time, and the lab time is just working time. But having these stand-ups and just syncing up more frequently is important. Because if you don't have these, then what happens is you have an iteration due, maybe like iteration 2, which you have 21 days to do. And if you only have normal weekly meetings, you end up meeting effectively like maybe twice, I guess, 3 times, yeah, whatever. 3 weeks, 3 meetings. You meet up you have 3 meetings before it's due, and there's a lot of work to do and more collaboration that needs to happen. So that's why these things are important. They're like little mini meetings along the way. Another really important part of any team trying to manage themselves is task boards or some kind of project management, project ticket tracking software. Now, some groups are interested in more advanced software than what we have on GitLab, and that's totally okay. Though for the sake of GitLab, GitLab has a task board built into it. You can find it if you go to the sidebar here and you go to boards. Now on these boards, you can actually see Emily's made a ticket here because she was probably showing someone, but it's like these boards, you can change the name of some of these things. I think if you click on that, I don't know how to change the name of it. No, I haven't used this in a little while. The way these boards work is they're essentially kind of made up of columns and then tickets. And columns represent statuses of work. A very typical board, I think I'll show you a board I look after with work. So like a board, here's a board for you. And this particular board itself is made up of 4 different columns, which is like tickets that we definitely need to get done, tickets that people are working on right now, tickets that people are blocked on, as in they're working on it right now, but they can't progress it any further because they're waiting on something else to happen, and then tickets that are done, right? And then typically there's also like a 5th column before all of this, which is like your tickets that we need to do sometime, but we're not going to do yet. Now, in reality, because this project is such a short time period and most of you aren't going to do work that isn't required, you're probably not going to really have kind of like what we'd normally call a backlog, which is essentially tickets that need to get done sometime but aren't a priority right now. You might have some of those, but I don't think you need to worry too much about that. So you can have a task board like this on GitLab. Open might be like your backlog, where you have like just anything that needs to get done at some point. In this case, to do is like things that need to get done. Doing and closed. Closed is like done. The words here don't really matter, and it's really important that you and your group actually sit down and figure out what matters to you here in terms of what makes sense. You can add more columns, I believe. If you can't, your tutor probably can. Add list. I'm sorry, I don't remember every detail about GitLab off the top of my head. I feel like you should be able to edit these. Add issues. Yeah. Okay. So maybe you can't. Maybe I've screwed something up. It doesn't really matter because you can go to issues. Is that what it is? Edit issues. Lots of stuff here to play around with GitLab. You can do it with add list and then press create label. Thank you. I know it's possible. Okay, create project label. So you say you want one that's like blocked and we want it to be like purple or something. I can go and create that right there. And then now I've got a blocked column like this. You can move some of these columns around. Generally speaking, you can't move the first and the last one around because I think open is meant to be like your backlog equivalent, which is like all of the tasks like that we aren't doing yet, but need to be done at some point. And then you have your closed column, which is done, and then you can kind of have a few different things in between. So, I mean, this is probably a pretty standard layout for most groups. you can obviously change some of these labels. And the idea is that when you have a piece of work to do, such as a feature, you might come along and say, oh, let's actually add a feature to say to do. I'll create a new issue called like implement auth register. So maybe this is something that you do when you sit down with your group and you go, okay, group, what are all the things we need to do at the moment? So you make an issue like that. Now you've got an issue here. And if you go back to your board, you should be able to see this issue and you might say, all right, well, this is in our to-do list now. And you can also assign it to people. So I could assign that, for instance, to Amy, who's one of the tutors, and now that's Amy's job to worry about. So it's a very, very simple, what would you say, way of tracking tasks. Walid says, the spec said that we need to use the GitLab task board. So what I'd say with that is it's a must unless you get the okay from your tutor, right? So like I'm not going to be marking your task board. Your tutor is. So ask your tutor if you want to use some different software. They'll make a judgment call on it as to whether they think it's a good idea or if the software is appropriate and stuff like that. So talking to your tutor is the answer there. So we've got our task board here. And the point is, this is how we want you to track your tasks. And this is something we will be expecting to see as part of, iteration 1, even if it's just for the last week. So if you've started working on this project and you've already made commits and you've made progress, that's fine. Don't worry about all of that. Just start with this from like today onwards or maybe like Friday onwards. This is how we expect you to track your work. Because it's a normal way that a lot of people would track their work. These task boards are super common. Again, the point of this lecture is not to get into like sprint boards and Kanban boards and all this kind of stuff, because you'll learn that as you go. You'll hear that. You'll put words and practices to particular concepts. And today's just about concepts. We just want you to really get the idea that like, okay, this makes sense. This is a way to organize things. You have particular states and then you have issues and they're assigned. And when Amy's working on this, she now moves this to doing, and when it's done, she moves it to closed, and then it's like, okay, great. Now, Amy's probably going to get some emails about that. Sorry, Amy. That's the flow of things and how they work there. I've already talked about this. I mentioned a blocked column. Maybe you don't need a blocked column. Maybe you need a testing column, but that's probably not useful for the project because of the nature of how we've asked you to implement it. So you probably don't need to have a testing column. That's okay. But yeah, you can set it up how you want. It's all going to be roughly the same depending on the group. This is probably the least relevant part of the kind of operational stuff that we're talking about today, which is this idea of sprints. You might have heard of this before again. What a sprint is in the world, and it typically is tied quite heavily to Agile software development, is a sprint is a fixed amount of time, typically a week or a fortnight, where you set a number of tasks to be completed in the team. After that period's up, you review what happened and you set more tasks. So it's kind of like you have a weekly meeting every week, you decide what you're going to get done this week, you try and do it all, and then next week you review it, you say, well, how much did we get done? What are we going to do next week? Sometimes you'll have to recycle the same tickets. The point of sprints as a concept is to try and give you a little bit of pace and perspective on things, where rather than again say, okay, we have this work that needs to get done. I'll see you in a few months. And then a few months is up and someone says, I didn't finish it, or I had some problems or whatever. It's giving you a chance to review things more quickly. Also, because as we said at the start, in terms of, the Agile philosophy, things change quite rapidly in software development. It's not uncommon to be working on a project and then new requirements come in, or you hire more people, or you lose some people, or something changes, or there's a more urgent priority. So this kind of ability to adapt is quite important, and most software companies will follow something like this, where it's like, here's your sprint, it's locked in, go do the work this week. We don't need to meet every day and reassess what you're doing. We can meet every day for stand-ups to chat about how this sprint is going. But we won't change the work we're doing until next sprint. Sometimes it's a fortnight, sometimes it's a week. I think fortnight is becoming a bit more common. One of the downsides of this kind of sprint mentality is that there are sometimes areas of work where people do just need to sit down and do work for a long period of time. And sprints can be kind of distracting, particularly for some deep research and stuff. In terms of sprints, when we talk about that, you set a number of tasks, typically what that looks like is that, say, at the start of a week, whatever that means to you, whether that's like your lab time or something else, and you figure out what work you're doing that week, you kind of fill up your to-do column with all the work you're doing that week, and all the work you still know you need to do, but aren't going to do this week, you tend to have in your like open column or your backlog column. So again, open is like all the work that needs to be done that isn't actioned. To do might be like all the work that is going to get done in this like sprint, i.e. this week. And then once you start working on it, you move it to doing. And then once it's finished, you move it to done. That's kind of the general flow and process here. Now, sprints I think are really hard to get right in a project like this because it's so short. Like we're already nearly 2 weeks into it. It's kind of the project wraps up in 7.5 weeks. So you're talking about 7 sprints or whatever. So what I would encourage you all to do is not to get like super serious about this one in terms of, oh, okay, we got this sprint. These are the tasks. No, we can't work on this as not part of this sprint. Don't get into that world. You can, but I would guess that on average, it would probably trip you up more, and you're all learning still a lot of things. So it's just keep it a little bit more light and simple in terms of, have a weekly meeting. You can call it a sprint if you want, put some tasks in, but things will change. You'll learn a bit, you'll change things up. Try and just think about these as like every week you want to kind of have a moment where you actually have a big meeting and you can actually reflect on what's gone on, and you can figure out what you want to get done in the next week, and you can go and try and do that, and maybe things will change. So just try and get the concepts of sprints down in your head. Weekly, fortnightly is probably not that useful given the nature of the project, but like weekly's fine. And you're going to have a weekly meeting anyway, which brings us on to the last point here, which is meetings and meeting minutes. It's a good idea for teams to have more formal meetings at least once a fortnight. That's like the requirement we're making. You should really do it once a fortnight at least, but I would strongly recommend once a week. It's so easy to meet up. You're already having weekly labs anyway. You're already doing the project check-ins. Like, just meet up every week is my recommendation. I mentioned here, typically this meeting would fall into some kind of sprint-style meeting, though in the absence of sprints, just a weekly meeting is adequate. Just a weekly meeting to say, what are we going to do this week? Sprint's just a name. We're more interested that you actually try and follow some general, processes. One thing that's super important is that during these meetings, we want someone in the team. You can rotate this around. It can be the same person or term. I'd probably recommend that you take turns doing it. We want someone to actually keep meeting minutes. Someone who actually takes some notes during the meeting. I've taken a screenshot of some meeting minutes from a 45-minute meeting that we had 6 months ago at work. And essentially it was like, okay, well, this was the day of the meeting. This was who came to the meeting. These were the things that we wanted to talk about. You often talk about more than that, but these are like the things that you definitely want to talk about. And then we had all the notes we took, most of that was just me making notes about things. But it's kind of like, redacted. So that's kind of the gist of it. It doesn't have to be super extensive. Oh, my stupid fat head's in the way. There we go. Yeah, it doesn't have to be super extensive, right? It can just be like, oh, yeah, this little dot points, whatever. Usually it's the name of the person and some kind of detail, whether it's like an action or just a note or something. What I would say is that it's very easy for your team to do the date, the attendees, and the notes. Agenda might be harder because in smaller teams, you tend not to like bulk up problems till the end of the week, right? Like if there's a problem, you tend to just talk about it and solve it. But sometimes there's 1 or 2 points, like how are we going to do this particular thing? Maybe it's a Friday and you have a meeting on a Monday and you realize that none of you have started a particular part, a particular feature, and you think, oh, we should really talk about it on Monday. So you add a meeting note there. Vincent's asked an excellent question. How do we upload our meeting minutes to the project repo? Cool. So there are 2 things here. One is, 2 ways you can approach it. One is you can actually have a meeting minutes markdown file, if you'd like to, like the assumptions file or a text file in master. That's totally fine. Well, it's actually 3 things. Wally's just reminded me. There's also a wiki page in GitLab somewhere. I don't know. I have a wiki down here. I don't actually think, some of you might not have the permissions to create or modify pages, but your tutor can help you out. you can actually create a wiki page here called like meeting minutes or something, and create that page content. And you can actually work on this together, I think. You can edit the page. So that's like number 2. You can create pages and wikis. Great, that's good. You have all the permissions to do that. The third thing you can do, which we started being comfortable with last term, is that if you'd like to, you can actually just do all of this in a Google Doc. And just keep a link to that Google Doc in your project. Like create a file called minutes.txt and just leave a Google Doc in there and push that link to your repo so the tutor can find it when they're marking you. That's totally fine as well. The main thing we're interested in is history, right? We need you to use a tool that unambiguously has history, because I know this sounds like whatever, but it's like if you write all your minutes at the last, like just before submission, not good. We're going to be mad. Not mad. We'll just be disappointed. But you actually won't even be disappointed. You just won't lose a couple marks. So try to make sure that you can either use the wiki, you can push to GitLab, or you can use Google Docs and share a link. All of those things have good versioning where we can actually check the history. A quick question from Masoni1 has asked, what's the difference between a text file and an MD file? A text file is just text like you're used to. It just has ASCII characters in it. A markdown file, though, actually has a particular little language. It's kind of like HTML Lite, where you actually write the markdown file like this. This means header, this means bold, this means header, smaller header, this means dot points. And then when it comes out, it actually looks like formatted. So it's markdown as like a way to super lightly format a text document. It's kind of like somewhere between a web page and a raw text file. It's friendly. It's friendly and easy to use. It's fun to play around with. You can play around with it with your team. It takes all of 2 minutes to learn because most of it's just headers and dot points, really. So we're coming up on 10:55 now. We're at the end of this particular lecture. It's pair programming. Yeah, I'll quickly mention this. I mean, I think this is taught somewhere else in CSE. I can't quite remember. Pair programming is something that's great to do. You can do this for the project if you want to, though you have to take turns in doing it. A common way to kind of maybe do pair programming is that, let's say I'm doing pair programming with Blake and we're working on the auth register feature. I'll get on a Zoom call or a Teams call with Blake. I'll have my code up, sharing screen, writing code, and Blake will be there kind of watching the code, and we'll be talking about what I'm writing. So typically it's like one person writing code, 2 people discussing code. It's a good thing. We're not expecting you to use this in the course. It's another throwaway comment because it's a great way to actually program. If you do it, though, it's really important that you take turns, because why did you not contribute to Git very much? Oh, I did. We were pair programming and Blake was doing most of it. That's not an excuse, because we'll just be like, well, that's okay a little bit, but you should have been taking turns. Right? Pair programming collaboration is great. If you collaborate with anyone, you get a fail. Yeah, so that's funny. Pretty much, obviously we don't want you doing this with the labs, though for the project it's totally fine because, it's already collaborative anyway. Just make sure you're actually writing code, because we expect still a balance of code being written. That's pretty much it for today. We've got a few minutes until I should probably end the stream. Waleed, if you want to ask your question about comp sci degrees, please feel free to. I'm just going to leave this up for the last couple of minutes while we tie off any last questions, or please fill out the survey for 2.6. As we get deeper into the course, I think this week has the most lectures. It has 6, which is just because we break lectures up as much as we logically can, so then they're in nice little chunks. In later weeks, we have typically 4, I think is pretty common. Oh, Rahman, sorry, it's just the same color. You and Waleed have the same... you're both orange on the chat, so my eyes were just reading the text. Sorry, Rahman, what's your question? We're done, by the way, for anyone streaming or watching the recording who just wants to get on with their life. Rahman says, I was wondering, for the minor, can we just take other comp courses which aren't part of our core units? Yeah, I mean, if you have electives to do, then Yeah, you can just do any. I mean, they talk about minors in CSE. Sometimes they refer to them as streams. It's really just a collection of courses that are thematically relevant. So there's like an AI stream and there used to be a game design stream or like I don't even know like what is it? It's like computer science UNSW minors or streams. I don't know. They used to have a way. I haven't looked at this in years. Uh, I have no idea where it would be, but they used to have some stuff. But I think it used to confuse students because students would be like, "Oh, I have a minor in this," but in reality, I don't think it ever appeared anywhere. So they changed its name to something so that you wouldn't get confused. Oh, is it? Oh, maybe not. I don't know. Streams. It's all very confusing. I actually don't have great answers for you. I might get some things wrong. Um, Yeah, like they used to have stuff like this where it was like, if you're interested in like databases, then this is the program you do it in, and then um, uh, yeah, you have to do these courses. But I think the problem with this was that it wasn't ever on your on your certificate at the end. So people were like, "What is this?" And then it was just I think it just started to become more. These are your recommended courses if you're interested. Oh, am I missing stream with minors? I don't know. That's probably the shortest answer here. I'm just trying to be as helpful as I can be, but I don't know. I'm just speculating based on what I remember. Um, but again, I'm not 100% sure what some of this stuff ends up to, like in terms of formally. I still think everyone ends up with a comp sci degree. Maybe there's minors. I don't know. So let's leave it there and say I don't have good answers for that one. Sorry, Ramen. I have very poor answers that are probably missing a great deal of context. Um, but minors are. I mean, just think of minors as a selection of courses if you're interested in a certain topic. Yeah, I still have the Doge shirt. It's still sitting in the cupboard. I don't think I've worn it for 2.5 years. Um, Yeah, you can do a psychology minor and a CS degree, I think. I mean, it's probably best to talk to Nucleus Hub about some of that stuff too. So if you do have any questions about programs or minors, go talk to the Nucleus because I mean that's where I send students anyway because things change around UNSW so rapidly sometimes too that um, you know I can't keep up. That's why I send students there because otherwise we'll give them the wrong advice. Anyway, it's 10:59, so thanks everyone for coming today, and see you all next Wednesday. And we'll send you a notice tomorrow with some more fun updates and everything else. So have a great weekend. See you soon.